Welcome to Mackey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. In this problem statement, a pentagonal pyramid 25 mm sides of base, 50 mm axis length rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and appears to be inclined to VP at 45 degrees. So we can understand that the type of solid here is a pentagonal pyramid, and each edge of the pentagon measures 25 mm, while its axis is 50 mm in length. Also, the resting condition is it is resting on one of its corners. Also, the two edges containing this corner are making equal inclinations with the HP. And the next condition is with respect to the VP and HP, the inclinations. So it is the axis of the pyramid which is inclined to the HP at an angle of 45 degrees and appears to be inclined to VP at an angle of 45 degrees. So here the beta angle itself is mentioned. So this is a non-beta angle problem. So now we'll see how to draft the solution for this problem. So let us select a continuous line of thickness 0.18 mm to draw the XY line. Let us annotate this line as X and Y, and also the reference planes as VP and HP. Now let us draw the pentagonal pyramid, the top view of it. So for that, let us select a line of thickness 0.50 mm. So let us first draw the pentagon and then rotate this as per our required condition. So the edge length is 25 and the angle is 72, followed by 25 and the angle 72 into 2. Next is 25 and the angle as 72 into 3, followed by the edge length 25 and the angle as 72 into 4. So with this we complete the construction of the pyramid top view. So now we will just align this. So for this, let us select the midpoint option from the entity sketch and then go for the rotate option. Ensure the copy is off. So from this corner, draw a imaginary line to intersect with the midpoint of the opposite edge. Now rotate this until that particular median is being parallel to the XY line. So this is the edge condition. But here he very clearly tells that it is resting on one of its corner of the base. So we have to have a corner towards the right hand side of the observer. So we're going to rotate in this particular direction. Also the condition is the particular median is parallel to the XY line. So here you can just see that this is the corner on which it is resting, and the two edges which is containing this corner are making equal inclinations with respect to the HP. So we'll just move this to an appropriate position so that we can draw the projections. Ensure the copy is off. So now we'll just move this. Now we shall draw the triangular faces of the pyramid. So for that, let us select a line of continuous type of thickness 0.50 mm. So from this corner, join this to the midpoint of the opposite edge. Similarly, from this corner, join it to the midpoint of the opposite edge. And from this corner, repeat the process. From this corner, complete the process. So using the trim option, trim these lines to get the triangular faces. So this completes the top view of the pentagonal pyramid. So now we'll annotate this. So we will tell that it is resting on one of its corner A, and we will go in the clockwise direction for annotating the corners. And this is the apex O, and inside the square bracket O1 represents the center of the bottom face of the pyramid. So now we shall draw the projection lines from each of the corners to get the front view of the pyramid. So let us select the line option again of thickness 0.13. So let us draw the projections. So we'll just keep the midpoint off. So from the corner A, intersect the XY line. From the corner B, through the corner E, intersect the XY line. Also from the apex point, you can just see that this line is not exactly 90 degrees. So just change the angle to 90. Also from the next set of corners, that is C and D, draw the projection lines. So now we have got the point from where the axis could be drawn. So let us go for the chain line, and from here let us draw the axis of length 50 mm and also complete the front view. So for that, select the continuous line of thickness 0.50 mm and connect the end point of each projection lines. This completes the base of the pyramid, and from each of the end point connect it to the apex point so that we get the triangular faces of the pyramid. So this completes the front view of the pentagon pyramid resting on one of its corners on the HP. So we shall annotate this. So this is O dash and this is O1 dash, which is the axis of the pyramid. So O1 dash, and next this is the corner A dash, and this is the corner B dash, which is visible to the observer, and inside the bracket it is E dash. And next here we have got the corner C dash and then the corner D dash inside the bracket. So this completes the front view of the pentagonal pyramid with its resting condition on the corner. So now the next part of the question tells that it is having its axis inclined at an angle of 40 degrees to the HP. So for that, let us select the front view of the pyramid along with the axis line and also the base of the pyramid and also the annotations. Go for the move option, ensure the copy is on. So keeping A dash as the reference point, move it towards the right hand side of the XY line. Now let us rotate the base of the pyramid in such a way that the axis will be inclined at an angle of 40 degrees. So for the base, the angle of rotation will be 90 minus 40 with respect to the HP. So this is the position in which the base shall be inclined. So now you can just measure the angle between the axis and the reference plane, which is equal to 40 degrees as per the required condition. So you can just extend this. So this is the 40-degree inclination. So this completes the top view of the pyramid with its axis inclined to the HP at an angle of 40 degrees. Now we shall draw the projection lines to get the top view. From each of the corners, draw the vertical projections downwards. Also from the axis, draw the horizontal projection lines. So you can use the trim option to trim the projection lines which is not required for our construction. So now we will construct the top view. So select the continuous line of thickness 0.50 mm. So we'll start from the apex, or we'll start from this corner A, which is the farthest corner. So here it will be the dotted line. So from A to the corner E, it is the dotted line, and also from A to the corner B, it is the dotted line, and also from A to the apex point O, it will be a dotted line. So use the trim option to just trim this line. Okay, so now we have completed the hidden edges. Now we'll cover the outer edges with a visible line of thickness 0.50 mm. So from the corner E to corner D, followed by the corner C, and from corner C to the corner B. So now we'll complete the triangular faces. So from each of the corners, join the apex, so that will get the triangular faces. So this is the top view of the pentagonal pyramid, resting on one of its corners and its axis inclined to the HP at an angle of 40 degrees. So we'll annotate this. So the corner AB, and this is the corner C, corner D, and corner E, while this is the axis point, which is O1. So use the trim option to trim the projection lines. So this is not required. So here we will just make this a separate entity, so that we'll get the point O1 for the next position. So use the thickness of 0.13. So from here till here it is O1. So this part of the line can be made a chain line to indicate that it is a axis line. Okay. So with this we complete the second position. So he very clearly mentions that the axis of the pyramid appears to be inclined to VP at an angle of 45 degrees, so which tells that the given angle itself is the beta angle. So with this condition, now we shall construct the third position. So for that, let us take the line option of thickness 0.13 and draw a line of any arbitrary length, but the angle of inclination will be 45 degrees with respect to the VP. Use the angle between, measure the angle, so it is 45 degrees. So on this 45 degrees, I need to have this OO1 inclined. So for that, select the top view of the pyramid, make it a rigid set. So select all the edges and the slant edges as well, and the annotations along with the axis line. So now we'll go for the move option, ensure the copy is on. So keeping O1 or O as the point of reference, place this point O on this 45-degree line. And now use the rotate option. So keeping O as the first point of rotation and O1 as the second point of rotation, tilt it in such a way that it is superimposed on the 45-degree line. So this is the top view of the the third position. So now we will complete the front view. So for that, draw the projection lines from the apex and as well as all the other corner points. Also include the axis. Now draw the projections from the top view. So the apex will intersect here. Corner A is on the XY line, while B is here. And then the corner E is here. D is on this line. Similarly, C is also on this line. So the projection lines must be exactly 90 degrees. So from the point O1, let us try to intersect the projection from O. So now use the trim option. You can trim the projection lines which is not required for the construction. So A is here, B is here, and this is the projection from the O. So it will end here, and this will end to this point itself. So we have completed the projection lines to complete the front view. So use the line of thickness 0.50 mm. So also for the observer, here the corner E is the farthest point. So all the edges terminating starting from E will be the hidden lines. So now we'll see that. So we'll begin with the corner A. So the corner A, corner B, corner C, corner D, and then corner E, and then from the corner A. So the base of the pyramid will be completely visible to the observer because the direction of observing is from here. So now from each of these corner points, let us join the apex points. So this will be the hidden line because no two thick lines shall intersect each other. So select the broken or the hidden lines, and then also from the corner E. So this is the corner E. This will be a hidden line. So next, the outer edge will be the visible edge. So this is the visible edge. So with this, we complete the front view of the pentagonal pyramid. So we need to draw the axis line. So select a line of thickness 0.13 and the line type is the chain line. So from O1 to O, this is the axis. So we'll do the annotation. So this is the apex, which is O dash, the corner on which it is resting, A dash, and this is the corner B dash. This is the corner E dash, and then this is the corner D dash. This is the corner C dash, and this is the axis point O1 dash. So this completes the front view of the pentagonal pyramid. So we shall indicate the direction of the projection lines using the leader options. So with this, we complete the problem. So we have got a pyramid resting on one of its corner A, and the two edges containing this corner, that is AE and AB, are making equal inclinations with respect to the HP. And then the dimension of the edge of the pyramid is 25 and the axis is 50 mm. And then we have got the next condition wherein the axis is inclined at an angle of 40 degrees and appears to be inclined at an angle of 45 degrees here. So this is the solution. Thank you all for watching.